All right, well, hello everybody, and holy moly, we've got a show for you today. See what I did there, Dre? It's Tradecraft Tuesday, and today we are talking a stocking full of Tradecraft, a holiday hacker grab bag of Azure and M365 treats. Today we are going to show you just how much the line can be blurred between identity is the key word here, and how much of the line can be blurred between identities depending on where you are and how you authenticate and how you say who you are. We've got a couple of interesting little attacks to run through, a couple of little tech demos. So let's get started, Dre. So first of all, I guess I would just say that it seems that we are in an identity crisis. Again, see what I did there? This world is a little new to me. So for those of you who don't know me, my background is in big old enterprise Active Directory red teaming, right? So threat emulation as it relates to gigantic organizations, Fortune 500, big old Active Directory setups, Kerberosing, that kind of stuff. So the world of Azure and M365 to me is I'm a little new to it, and I continually have to pick my jaw up off the floor because of what I'm seeing. And so we've got a breakdown of a couple different. Oh, this is me and Dre, by the way. This is Dre, cybersecurity dude, and myself, one of the hackers on Earth. So what we've got for you today is a breakdown of a couple different attack methods when it comes to Active Directory and M365 that all center on identity. And so we're going to talk a little bit about how in the old days, what the concept of identity might have meant, and then how it kind of bifurcated around the time that M365 came online, and then kind of what that means in terms of tradecraft and emergent attacker activity. And so, yes, and of course, I will be getting it wrong. It is Entra ID now. I will be calling it Azure Active Directory. I will do push-ups every single time I say that. I won't do them now. I'll do them after the webinar, and I'll just have to, record myself or something anyway. So what we're talking about today, I've got 3 little breakdowns for you. I've got 2 tech demos for you. And what we'll talk about today is token theft via Evilginx. We're going to talk about access token theft via stealing access tokens right out of Office applications. And we're going to talk, although I will not demo this, we're going to talk about skeleton keys and the incredible damage that you can do if you can land a skeleton key in an environment. So I guess the intro here, how we kind of got ourselves in this position, is that cybersecurity cobalt strikes are not the only thing that are up 161% year after year, folks. Identity, and this is all from, by the way, this is from the SMB, the threat report, the SMB threat report that we just put out. I know there are no pitches during Tradecraft Tuesday, but this is free. All you got to do is sign up for it. So go download it. So it turns out that identity-based attacks are up in a big way, and I think there are a lot of reasons why that is. I think one of the biggest reasons why is that identity attacks, the infrastructure that you have to compromise to carry out an identity-based attack or an account takeover is basically right in front of you always. That's just kind of how Azure works, or rather M365 works. And business email compromise, which is our next slide here. Business email compromise is a tantalizing target for hackers, right? So if you can take over an account of somebody who is in the process of carrying out some kind of business transaction, and you can, fool or otherwise dupe somebody into paying you when they should be paying somebody else. Well, that's just, I've seen this happen time and time again. Even before I was at Huntress, I saw this happen, even to my friends, and you would hear stories of how they would say, I thought I was talking to them in my email, and lo and behold, I wire the money and then they empty my account, and that's where we're at now. So business email compromise, big problem, but business email compromise is a final action, or not, maybe not necessarily final, but it is later in the attack chain, right? And so if we rewind the tape a little bit, we've got to look at how threat actors are compromising identities and getting into these environments in the first place, and then other little stops along the way is maybe how do they persist? How do they execute against the environment? So that's what we'll talk a little bit about today with these demos.
But Matt, just to pause on that, what you said
Yes,
there
of
is
course.
super interesting, dude, because you mentioned the attack chain, and some people are going to be like, what do you mean attack chain? When's that coming? And like for folks that aren't too sure, that's kind of like the cyber kill chain, or you can go onto MITRE attack and look at all the steps. But what's cool is that, yes, okay, if you're attacking on-prem, if you're attacking on cloud, you've got to follow sequences. They may be similar, but what's cool about cloud or user identity compromises, it's a shorter attack chain to get to your
Yep,
objectives.
actually.
And
Check this
oh,
out.
damn, he's got the
Yeah,
links.
I brought it up.
He's
I don't know why
got the
there we go.
links.
Oh my goodness. It's it's of course being very slow when the demo gods are not kind to me. But check this out. So whereas the full MITRE attack matrix, and if you're not sure what you're looking at right now, this is a map of how cyber criminals do the things that they do, right? And so there are different matrices based on the different kind of like battlefields, I guess, if you want to look at it that way. But this is the one for Office 365, still in fact called Office 365. So it's much shorter. And whereas in the realm that I come from, in the big kind of enterprise Active Directory red teaming world, you've got to fish to get in the environments, and then your beacon drops on the endpoint, and then you've got to install persistence, and then you've got to look around and you've got to say, where am I in this environment? And you've got to do all these things. The attack chain here is like extremely short. It's like account takeover, look at their emails, do the thing, and then egress from the environment, right? So yes, the amount of tactics that are available to threat actors in the M365 space are fewer in number than they are in other areas, and that naturally lends itself to the attack chain being a lot shorter. So what that means is that when this stuff goes down, it's fast. It is very fast. So yeah, you know what? I will throw that in the chat as well. That's what I was just looking at. All right. Any other questions? I will try to pay attention to the chat, but sometimes I get in the zone.
I got you, man. I got chat. I'm also throwing in links for stuff, so I threw in the MITRE one already.
Oh yeah,
do
thank
your thing, man. I got you. And folks, do abuse the Q&A stuff. You've got two very talkative people. Will tell you everything you know. And if we don't know, we'll make it up. It'll be fine.
Yeah, I appreciate you, sir. All right. Evilginx. Evilginx. The first thing that we need to get on the table and discuss right now is, how do you say the name of this tool? Because is it Evilginx? Is it Evilginx? I don't know. You don't know. I don't think anybody but the creator knows. Whatever you decide to call it, it's this handsome guy right here. I love the icon for Evilginx. He's got so much tude, he's just got the tude. This is my very unscientific graph as to where you are in the attack chain. Notice that there is no labeling on this. It's just basically like, without any specific identifiers, where are you in the scope of the attack at this point? And this is pretty early on. This is like, as an attacker, after you have scoped out the environment, but before you have actually gotten access to the environment, you're going to be running some kind of Evilginx attack. So what does this thing do? This is a transparent proxy. So this will sit. So you as the attacker will sit between, and they call this adversary in the middle now, AITM. You will sit between the person that you are trying to compromise and the M365 in this case, although Evilginx can be used for a lot of different kinds of authentication. You're going to sit in between the person you're attacking and the M365 login page. And you're going to fabricate and make it look extremely convincing that you have a page that they're going to log into. You send them a link in a phishing email and you say, hey, it looks like your account has been compromised. We need you to put in your credentials here. Please go to this link, and you supply the link, and please authenticate, and you will be totally okay, totally fine. Now, unbeknownst to this person, you have set this up so that their authentication passes through you as the adversary in the middle. It lands on the legitimate, in this case, Microsoft 365 page. The authentication takes place. It comes back to the adversary. they capture the session and then they allow you to continue on to the M365 portal. So you sign in, it's all legitimate, but it is the adversary in the middle that captures your session, and then they can replay that session by injecting it into their own browser, and lo and behold, they are now you. And this is another kind of like, it's a more philosophical bullet point here, but in the age of M365, identity is only proven insofar as the things that you have to show that you are that person. So in other words, identity is really an extension of, do you have, in this case, a session token? Oh, you do? Congratulations. You are this person. And so that can, and it's a gross oversimplification. There are defenses coming online right now that will kind of throw a wrench into that. But, you know, to simplify, if you can present a session token as a user, you're essentially that user, right? This tool is made by Kuba Gretzky, and Kuba has a whole course on how to get really, really good at Evilginx. And yeah, I believe it's OP. I believe it's extremely OP, and it needs to be nerfed. So Dre, without looking too hard at what you're looking at on the screen right now, what do you see in terms of, well, yeah, let me just ask, what do you see? What are you looking at?
I see a very legitimate Microsoft Office authentication sign-in, dude.
That's good, because that is, in fact, the actual
yes.
the actual Microsoft Online sign-in page, and you can tell that because of the authority here, the proof. In this case, and there's another kind of method where this might not be the case, but the authority here is that the URL we have login.microsoftonline.com. But what if I were to show you this one right here?
I see an equally legitimate authentication screen, Matt.
Yes, except there's one key difference. Of course, we're being a little ham-fisted here, I understand, but we gotta have fun with this. So you'll notice that up top there, https://login.whatevs.com. So this would be an example of how the adversary has dropped in and created a domain and stood up Evilginx, and in this case it's whatevs.com, but this can be a typo squatted domain. This can be something that looks really legitimate, and it's also made kind of more complicated by the fact that you can have custom domains for logging into M365. But in any case, this is an Evilginx portal as well. One other thing that I learned recently, Dre, you might find this interesting, is that if your organization uses some kind of custom artwork, so in this case, Huntress Labs, when I try to sign into Huntress Labs on Microsoft, they have like a little logo that pops up. And like, I believe maybe part of the reason why they did that was to be kind of like a proof of, don't worry, this login page is good. But no, doesn't matter. Evilginx will pass that right through, grab the art at the page, because it's basically just proxying that page, right? And it will present that however your organization has kind of decorated or dressed up your login page. That's kind of terrifying. I mean,
I know folks on this call, we're all security conscious people. We'll look at the URLs, we'll look at those kind of things. But for folks who are just trying to get their jobs done,
exactly,
they didn't see any discernible difference between those two images that you had there, right? Of the logins. And that's why as well, I think Evilginx is so insidious.
Yeah,
that it preys on people who are just trying to get their job done. So they're like, oh, you sent me a doc. Great, let me just sign in so I can download it.
Yeah, I have some slides here of the kind of attack in progress, but I'm actually just going to show that in the demo so we can move on here. This is a fantastic blog post that I found about this, because like it does no good to be like, here are all the attacks, good luck. There are lots of detections and mitigations coming online as recent as this year that are throwing a wrench into the adversary in the middle attack chain. And so this Jeffrey Apple blog post does a really good job of documenting kind of all of the new technologies that are coming on board and how they're going to mitigate certain parts. There's no like silver bullet here is the long and short of it, but there are ways that you can approach mitigating and detecting transparent proxies in action. But enough of me blathering, because I've got a little something to show you in the lab over here. So this is the tool, Evilginx. Again, love the dude, love the little icon guy. And so the way this sets up, oh, and by the way, My favorite cybersecurity YouTuber, John Hammond, has a fantastic video on this one. The way that you set this up is that you bring in what's known as a fishlet into Evilginx. And a fishlet is the thing that sits between the actual login page and the person you're trying to, attack. And it will kind of broker the transaction. It'll say, okay, as this person visits my page, I'm going to take these parts of the web request and just forward them along. And then I'm going to take the response from the legitimate Microsoft 365 sign-in page, and I'm going to forward that along. And it just kind of like, it shuffles it in between the two endpoints. So the idea here is that when you stand a fishlet up, you are going to generate a lure. And so a lure is the actual phishing link that you will present to your target. If you attempt, in its default form, if you attempt to access the Evilginx endpoint and you don't use a lure link, you are redirected to a configurable redirection URL. Does anybody know what the URL is if you just run Evilginx out of the box? It is, in fact, the Rickroll. So that's fun. Learn that the hard way. So if we do get URL and 0 for our lure here, we've got our, and this would be in a legitimate situation. This is your evil domain that you've stood up. So if you've typo squatted or you've otherwise put up a domain that looks legitimate, you will take this and use this as your phishing link. So in the background here, that's the legitimate Microsoft online sign-in portal, but we're not interested in that. We have as the target, as the mark, we've gotten an email that says, hey, you've got to log in here or else we're gonna drain your account and bad things are gonna happen. Oh geez, okay, login.whatevs.com. Just a little to follow up on the I've probably got to here, I've got to re-authenticate, but to follow. Oh yeah, go ahead.
I was gonna say, while you're doing that, Matt, I was gonna say, folks are really curious about, hey, how do we mitigate this? And there, some people throw out some ideas. Two really quick ones. If you use like Windows Hello or like YubiKeys, that can frustrate an adversary. And second, a good conditional access policy around device itself. Now, remember this, I use the word frustrate on purpose. It's not going to stop a persistent adversary, but it is going to add obstacles. And folks, what you want to do is you just want to make it far too annoying for adversaries to target you and your users. And we can talk more in detail about mitigations and stuff, but I would really recommend, if you're not making the most of conditional access policies, please do. I know that they come with particular tiers of licenses, but if you've got it and you're not using it, that's how you can help frustrate adversaries from doing what Matt's doing on the screen.
Here we go. Okay, so just as a follow-up to having Evilginx pass through any of the icons that your organization may use. So you just saw that if I have been duped, if I, as Matt at Huntress, have been duped into signing into this, well, if I rely on the Huntress logo to make sure that I'm signing into the right area, well, Evilginx is going to pass that through to me, and that's kind of terrifying. But in any case, I have a test tenant that I can use for this. So let's say that I am, if we just get back to the regular prompt here, I probably have to just re-authenticate or else it's going to try to continually rotate me through and say, are you sure you're not this person? Are you sure you're not this person? But I have a test user here, a low privilege test user that I can use as part of my Husky Works testbed research environment. Now I want to show you, I will strategically cover it up with the window in the front, but if we do sign in, oh, look at that. We've got a couple, it's scrolling by very fast, but we've got a couple of these plus signs here. And so now I have authenticated and you can see username and password, and you can see the low PR for low privilege, but that is my username and password. Now that's terrifying. And it's not good if the adversary has a hold of my username and password. But if that were all that happened, we'd actually probably be okay. But what I'm about to do is authenticate and answer the MFA prompt. And that is going to seal my fate as the mark in this case. I punch in my MFA and I'm going to do the enter passcode. There we go. And once I have authenticated with MFA, if I scroll down here, we will have a captured session that has been intercepted. There are a lot of kind of debug messages here, but you see that we've captured my authentication session here. And now if I run the sessions command, we have a captured session, session 8, sessions 8. And that is and if you're fast enough, you can probably authenticate as me right there. So I would copy that. And with nothing up my sleeve, I can import this into my browser. And let's see if we can log in. Drum roll, please. Ladies and gentlemen, we got him. Yeah, John Hammond live demo, gods. Got him. So this is what we're talking about, because the fact that this thing can do MFA interception is actually what keeps me up at night. And yes, shockingly simple, right? Like, that is all it takes in terms of being able to trick somebody by emailing them that lure. And like you can see in that awesome John Hammond video, you can dress up that lure link with all kinds of stuff to make it look legit. But all it really takes at that point is the user to log in, provide their username and password, and then they have to, if they have MFA, hopefully, authenticate with MFA. That's it. And that's identity theft 101 right there, is Evilginx. So that, I mean, that's enlightening, right? Like, that's the kind of thing that we're talking about when we say that there is a new dimension of this battlefield, in that, like, identity is provable with somebody stealing your session token and using it to provide proof that they're you. And yeah, that's kind of crazy stuff. Keeps me up at night. And that was the demo. So,
Matt, we've got a bunch of people kind of asking and talking about the different licenses and mitigating this in conditional access policies.
Right,
Folks,
yeah,
we'll put some articles together, whether ones that we've drafted or ones out there, and we'll send that out to people. But the one thing I'll just come back to is make the most of the security technologies you've got, and with conditional access policies, there are folks asking about security keys. Again, if you've got them, great, but conditional access policies with the right licenses will really help you out here.
I just put the Jeffrey Apple blog in there. That was the one that I referenced in here. It's got some fantastic information on mitigating and detecting these kinds of attacks. Well, Dre, what do you say we move on?
Yeah, let's do it. And folks, make sure you keep abusing the QA feature. We're always happy to answer your questions.
So next up is another one, and I like this one a lot because it is another one of those attacks that kind of like, it blurs the line between like on-prem and identity-based attacks, right? And so we're going to talk about stealing access tokens from the running process memory of desktop applications. Now, I want to differentiate immediately. Oh, by the way, we're about here in the unscientific attack chain breakdown. So we have accessed an environment with a beacon in this case. So we are like Cobalt Strike, or, pick your favorite C2, and we have landed in the target environment via phishing or whatever, but we've got our beaconing out, and we're thinking about what we want to do next, right? And so this is one that blurs the line between what happens when you have on-premise access and what happens when you have cloud access, and how you can maybe move from one to the other. And so we are after our endpoint compromise, so your traditional like landing your Cobalt Strike beacon, but before you have actually compromised any identities, we're going to look around as an attacker and we're going to say, okay, I know that M365 is used in this environment, but what are some ways that I can move up into the cloud? And so one such way is that we can look in the process memory of something like the Office desktop application of Excel, and we can look to see if there are any access tokens inside of this process memory, and then we can steal those. So I want to differentiate here that an access token in this case is different than a session token. So those are two separate things. I'm going to show you what we can do with that access token depending on the scope and of what we find. And so, yes, Mr. Docs was the originator of this research. I learned about it from taking Sintra trainings, attacking and defending M365 and Azure course. But yes, Mr. Docs had the original write-up on this, and I'm simply relaying the information here to all of you. So we've got our Cobalt Strike guy here. And Cobalt Strike says, hey, I looked around on the endpoint and I found us a process that has to do with one of the Office desktop applications. I wonder what's inside. And oh, lo and behold, here is the sign-in information. And it looks like we've got Husky at huskyworks.onmicrosoft.com signed into this desktop application. Again, blurring the line here between what happens on-prem and what happens in the cloud, because now we have an identity associated with an application that happens in an on-premise environment. And so what we're going to do is, via any tool that we want to use for this, we're going to dump the running process memory from this Excel process. And we're going to carve into that process memory and look for access tokens. In this case, we're looking for a particular type of string. Those of you familiar with API and web security may know what I'm talking about. It's called a JWT, a JOT, and it is a proof of identity for that particular resource. And so they're used a lot in web security, but in this case, we have in the running process memory, because Excel needs to have authentication material to push and pull things from the cloud, there is an access token living inside of the process memory. So why don't we as attacker, we don't need any special permissions. We don't need to be, system or administrator or anything for this. If we are in the context of that user, if we have their permission level, we can carve into the running process memory of that process. And so I actually wrote a little tool to help us do this. It's based on another tool that I found in here. We can also see stuff like we can take this token and ask the Graph API to show us information from this user, but I'm going to demo that here in a moment anyway. But yeah, it's not hard to imagine how we can pivot this into full-blown M365 initial access or data theft. So let's actually do that demo. And we don't even have to be in the lab for this one. Caveat, kids, don't run malware on your physical machine. I'm a professional. I know what I'm doing for the most part. So don't do what I'm about to do at home for sure. But in any case, let's say that I have my Excel desktop application signed in here. And I'll probably have to two-factor my way into this as well, because I am a good security practitioner. I use two-factor on everything. And so I'm gonna sing the two-factor song while I put in my little code. There we go. And good. So let's say that I've authenticated, and as part of my daily duties, I am just, using Excel as Husky at huskyworks.onmicrosoft.com. And so let's say that we've got a cybercriminal, and again, for the purpose of demonstration here, let's assume that I've also been phished and I now have some kind of C2 agent running in my environment. And so I have been owned. However, I have not, at this point, the adversary has not compromised any of my identity-based anything. They've just gotten access to my endpoint. And so they're now looking around for their next move. And so I wrote a tool in C# for this called Sharp Token Finder. Let me find where I had that right here. Got to move things out of the way for this, but I released this on GitHub last week sometime. And this is a re-implementation in C# of another tool that I found called Token Finder, which is a Python script. So when I took a look at this tool will carve in, basically do exactly what I said, carve into the running process memory of Microsoft Office applications and look for a specific string, a JWT string. However, this is written in Python, and I thought, well, if there's no corresponding C#.NET version of this, well, I'm going to go ahead and write one. And the reason that I did that is because .NET framework allows you to run reflective assemblies, and that's kind of a common adversary tradecraft tactic and technique. So this allows its flexibility for if you want to use this through a C2 or not. But in any case, there's Sharp Token Finder. All you really need to do if you're running this through a reflective assembly, you will load it up in your particular C2 agents, but it will enumerate the system for any Office application, and it will dump out. Oh, beautiful! And I love when these things work out. It will dump out the tokens that are inside of each of these processes, and then it will present you with that information. And I made it all nice and green and colorful too, so it's cool. All right, cool. So the ones that are highlighted in green are the ones that I think are most, what's the word I'm looking for? Most ripe for the picking here, right? And so this audience, let's talk a little bit about what this authentication schema kind of presents. So when you have a JWT, you are going to have a couple different parts of it, right? So they're not all made equal. There's going to be a user that this JWT is assigned to. This is their access, right? So this is saying, okay, this is the person that wants to access this resource. There is an audience, all right? This is the resource that they're trying to access. And then there is the scope as well. And so if these three things line up, if the user and the audience and the scope all line up, you have exploitable conditions to steal information or possibly even leverage into initial access. You can even read emails. You can read OneNote notebooks. You can even, in some cases, if you have the right accesses, write mailbox rules, which is part of that business email compromise situation that we were talking about. So where I can actually go, oh, and by the way, these access tokens all start with EYJ0, capital J0. So I like to remember that with A Joe, like the Jimi Hendrix song, A Joe, where are you going with that access token in your hand? So A Joe is the access token for what we're looking for. And it doesn't say, but this audience right here, this special kind of like long number alphanumeric string right here, I believe, because this is highlighted in green, this should be the Graph API, right? So if we have stolen this token, and we can now take this token and present it to the Graph API. Guess what the Graph API thinks? It thinks that we are them. There is no, this bypasses MFA. There is, after I have authenticated to that desktop office application, there is, MFA is completely out of the question when we bring this kind of exploitation onto the field. And this is as easy as teeing up a curl request, if I spell bearer correctly. And that is saying, hey, we're going to authenticate to the Graph API, in this case, https://graph.microsoft.com. And now we have any number based on our token scope and audience. We now should have any number of resources that we can access at our disposal, because we are giving them the access token in this case. And we can say, for the Graph API version 1.0, for me, I'm going to go ahead and dump out, I got to spell the endpoint correctly, but let's go ahead and dump out all of my email messages. And so if we go to the Graph endpoint, v10/me/messages, and we present this token to the Graph API, the Graph API, for all intent and purposes, is going to think that we are that user. And so here we can see my emails. And so that's great. I mean, you can think of lots of different ways that we can abuse and perform follow-on compromise that way. But what about like OneNote/notebooks? I think we should get something like that too. Yep, there we go. And it looks like we've got some, let me zoom in on that too. We have, where to go? There it is. We've got our very sensitive information notebook right there. There we go. Very sensitive info. And so that's another example of stealing authentication for an identity from a process that's an on-premise running process on an endpoint, and being able to use that to leverage that into additional access. I can go into this notebook now. I can look around. I can see if they have, stored any passwords in there. What about SharePoint? Same thing. If the token scope allows you, and in this case, OneNote is basically SharePoint with a hat on. So I would not be surprised if it allowed you to do that. But yes, SharePoint, same thing. You can crawl SharePoint accesses. If anybody in here has heard of the tool Graph Runner, Graph Runner is a fantastic example of an offensive security framework built around stealing these graph access tokens and relaying them against the Graph API and using that to further your access. So go check out Graph Runner as well. Dre is so fast with the links, man. So fast with the links.
I've got to do something, man. You're doing the handsome work. I'm just here. But I wanted to meditate on something for a minute, man. So am I totally boned if this happens? Like, what can folks do?
So
prevent
yes, so
this?
mitigation and detection in this case. I mean, we're talking similar things here. Conditional access policies are going to, you know, a lot of mileage, get you a lot of mileage in that case. I'm doing this all from my endpoint, but imagine that if a threat actor has dumped out the running process memory of your Office application, and then they don't have to stay on the endpoint, they can move offline to their evil infrastructure somewhere. If they then relay that against the Graph API, the Graph API is going to see their IP address as the originator of that request. And so a conditional access policy in this case would say, hey, I know you've got the right access token, but I see you're logging in from, you know, wherever, and I'm not going to allow that to happen. And so that's like one of those examples. Obviously, endpoint detection EDR capabilities are going to maybe hopefully see if a C2 agent is running something like Shark Token Finder. That's a different tool. Sharp Token Finder. So hopefully if the threat actor uses like reflective assembly to do that, maybe an EDR is going to be able to smack that down. So that's another potential way here. But yes, if you anticipate that this has happened in your environment, revoking these access tokens is also a mitigative step here as well.
And so, Matt, that we had someone say, hey, man, would token binding stop this? So for folks that aren't sure what token binding is, I think it's a newer feature. And it's going to sort of link the access token to the browser. And that sort of, again, it frustrates the adversary. It's not going to stop them. The other thing you can do, and I've seen this done with some success, but it does come with a little bit of frustration for users, if you limit the lifetime of the actual token.
Yes, true.
Then the utility of the token is only as good as the adversary can go and get more. The trade-off for that, your users are going to have to sign in more. Users don't like doing that. So it's a balance. Sure. It's a balancing act. I'm not going to pretend that when I was a junior sysadmin, I enjoyed having to deal with those kind of things, but it is better than what we see adversaries doing once they gain access to your user identities.
Let me check one last time in my detections and mitigations notebook for this one, just in case I missed anything. But I think we have covered all of that. Yeah, you know, my notes for detection and mitigation here focus on the Azure sign-in logs, right? Non-interactive or interactive sign-in logs, initial access to M365 apps, and JWT access. So look for when, you know, if there's an incoming token type with the primary refresh token, that's one of the giveaways for this kind of thing. But yes, otherwise, endpoint forensics to maybe to see if the dumping of the running process memory has happened on that endpoint. But endpoint memory forensics is scary, so I'd understand if you didn't want to go that route.
And someone anonymously says, sorry, Matt, can you give the link to the token theft tool?
Yeah, sure. So that's two in this case. Yeah, so
it's already been linked in the chat.
Yep. So
scroll up,
and you can scroll, but then there's also the one I built this from is the Python script, which basically does that, but is a Python implementation. But adversaries, for the most part, don't really want to operate in Python by running scripts on the endpoint if they can help it. One, the Python interpreter might not even be there, and two, running tokenfinder.py in your environment is a surefire way to skyline your operation and get you booted out. So at least in the C#.NET implementation, you can run it with a reflective assembly, which is like a little stealthier. But, you know, your mileage may vary. Anyway, this is not a webinar about red teaming. This is a webinar about identity and M365 attacks. So let's move on. The last one that I have to present to you today truly is something that keeps me up at night. And I don't have a demo for you for this one because it is so dangerous. Your safety is not guaranteed. No, that's a lie. I just don't want to mess up my lab environment to show everybody this. But so this is spooky, scary skeleton keys. In my non-scientific attack graph, you are here. In fact, you are here if you have found yourself in the position where a skeleton key has been installed in your environment. Show of emoji hands in the chat, please. How many people out there have heard of the Active Directory skeleton key? Not the M365 or Azure one. How many people have heard of the Active Directory skeleton key? Couple. Yeah, couple hand raise. I like people using the Zoom hand raise, which is like that's funny. Okay, so yes, so again, Active Directory Enterprise Red Teamer. I was familiar with the Active Directory skeleton key. For those unfamiliar, if I had, and this is way further in the attack chain, but if I have leveraged credentials to the point where I am like an administrator or a global administrator, I can patch the authentication service in Active Directory to allow, really, I can do anything I want with it, but in most cases, I can write it in, I can write logic into the process to say, hey, if anybody authenticates with their password or the string mimikatz, because mimikatz is the way that you normally do this in most implementations, allow people through to authenticate. So that it's a skeleton key because it allows you to patch that authentication process and say, okay, allow everybody to keep using their passwords, but me, I'm smart and I'm just going to type in mimikatz, and that works for any user account in Active Directory. And so that is the skeleton key in Active Directory. I knew about that one. I did not know about this one. So this is a nightmare scenario. So it's easy for me to be like, the world is ending and like, you know, everybody should stop what you're doing and like look in your environments and stuff. But the truth of the matter is that there are many preceding conditions that are required for this to actually happen, right? And so this is in Active Directory environments that have Azure pass-through authentication enabled. So I have a good graphic on the next slide here about how this kind of looks like. Basically, think that in Azure, and if you're using M365, you're using Azure, whether you kind of realize it or not, there are a couple different ways that you can authenticate. And so one of those ways is to just go straight to Azure and authenticate that way. And all of the passwords and everything are stored up in the cloud. The other way, if you And so pass-through authentication is one such way that you can configure this, which means that, and I'll show to the next one, as you right here, as the user, authenticate to the cloud will then contact an agent that lives on-prem for this organization, and it will say, hello, agent, I have a user that wants to authenticate, and I need to check their credentials to see if they can have access to our Azure environment. And so that agent will query rather the domain controller. Sometimes this agent is installed on the domain controller. In fact, it usually is. And then it will say, yep, credentials look good we checked it against our Active Directory and they are okay. So go ahead and return the okay for them to authenticate. And then they can log in and authenticate to the cloud and all is right in the world. But if you noticed that the process that is responsible for this is called Azure AD Connect Authentication Agent Service.exe. Mouthful. There are new ones. There are, it's like Entra Connect or something like that, but this is the one that I'm familiar with. And so if you, as the attacker, have compromised and developed your accesses to the point where you are now looking down the barrel of this Azure AD Connect Authentication Agent Service.exe, and you have the you have the privileges necessary to be able to manipulate that process, you can inject a DLL into that process. And just like the Active Directory skeleton key, you can basically make this thing do whatever you want it to do. And so in our visualization here, let's say our Cobalt Strike guy here has landed next to this authentication service process and will inject their DLL right into this process. And that begs the question, what might you be able to do when that happens? It turns out, and this is, there's another conversation whether this is the right way to approach this, Microsoft, but we don't have to unpack this today. Turns out this authentication at the API level happens in plain text. Ouch. So what that means is that if you can hook this API and inject your DLL, you can create your new log on user W API call, which is the API that actually authenticates users in this case. And you can rewrite this to do whatever you want. In this case, the one from the example, which was by Dr. Azure AAD Nestori. Yeah. The example is called PTA Spy. And it will write out, or possibly this is the one from the Varonis blog, I don't quite remember, but it doesn't really matter. You can implement this any way you want. You can write out these passwords to a text file. If you're, handy with C++, you can have it, make a post request to some webhook or maybe a server you control. And then the real coup de grace here is that you can set the skeleton key in this case so that if the password is hacked, or if the password is Mimikatz, or if the password is 123fish, doesn't really matter. You can pass that authentication right on through, and you can log that user in. And does anybody in the audience see kind of the insane implications of this? Like, if we think about that for a moment, what does that mean? That means that if you have skeleton key patched the environment and you're allowing a string of hacked or Mimikatz or maybe no password at all to authenticate, you're now opening up, because this is Microsoft 365, this isn't an on-premise location anymore. You're opening this up to allow anybody on Earth, save for some kind of conditional access policy or geofencing or something like that. You're basically allowing anybody access to this skeleton key. And so if the string is hacked and you tell your friends that the string is hacked and they put that in as their authentication, well, guess what? Ding, ding, we got a winner. Or if there's no string at all as well. So yeah, scary stuff. But what's really going to blow your mind? I love it. It's like layers, man. There's layers to this. What's really going to blow your mind is that there's two ways to approach this from the attacker's perspective. You can approach it that you have compromised their on-prem, you've developed your accesses to get to that Azure AD Connect process, or you can approach it if you've compromised their M365 at the like hybrid cloud administrator access level, or the global admin access level, or just the administrator access level. You don't even need to be on-prem to do this. You can download their pass-through authentication agent to a computer that you as the attacker control, and you are completely out of band at this point, and you can still hook in that DLL to that process. And because you have the agent running authenticated to pass through, you can hook that DLL in, and the skeleton key works just that way. So almost like a silver ticket, kind of. There's an analog to the silver ticket here, but yeah, yeah, you're in the right kind of mind frame there. So yeah, so this is, and if you want like a little kind of too long didn't read about how you would pick up on something like this, this is a screenshot from Sintra Training's Attacking and Defending Azure M365. So in the pass-through authentication section of if you as the legitimate, administrative user, if you go to the pass-through authentication section, you'll see that you'll have like your domain controller, dco1.assassinkitty.com, and that's good, right? Yeah, that makes sense. And then maybe you have like PCO1 if you've installed it somewhere else, but then you'll have like just this random rogue desktop whatever at an IP address that you probably don't recognize, and that is a telltale that the attacker has moved the skeleton key offline for your pass-through authentication. So that is, I don't have, unfortunately, like I said, I don't have a demo for this. I didn't want to break my lab, and it was coming down to the wire if I was going to be able to pull off building a separate testbed environment to show this one. But also, if I did install that skeleton key, then all of you would be able to access my Active Directory environment. I believe multi-factor authentication will still save you in this case, because the authentication is still username, password, and then multi-factor in between that. But for those accounts that do not have multi-factor authentication, and I know you're out there, this is a scary one. It's only in hybrid environments. Yes. So I actually have data about this. So I looked up in our portal how many of our partner organizations run the Azure AD Connect authentication agent service, because I just wanted to get an idea of like how prevalent this might be. And it's a little under 200 organizations. So that it's not insignificant. Like, it's not everywhere, but it's not insignificant. And yes, this is an attack specifically against hybrid environments. So yeah. Anyway,
Matt, we had a question. Someone says, "Hey, in this example, does the domain controller need to be compromised to inject in the DLL?"
Possibly, but not necessarily. If you notice in this one right here, you can install the Azure AD connection agent really kind of anywhere. And a lot of times it's going to be on the domain controller, but it might also be on your ADFS, your Federation service server as well. And so, yes, the long and short of it is treat those servers like they are critical, because they are. Because in this case, if an attacker gets a hold of them, if your Cobalt Strike guy has landed on your ADFS or your domain controller, and they they can wreak all kinds of havoc, but this is just one of the things that they can do if they find themselves in that position.
And I just want to reiterate, Kat in the chat kind of used the reference to the term tier 0. And Matt, you just referenced treat that like sort of nuclear protection. If folks aren't familiar, tier 0 to 3. I think Microsoft like deprecated that language, but it's still a good way to think about things.
Right, yeah.
Tier 0, nuclear protect. I do everything you can to protect that. So these could be your backup servers, your ADFS, your domain controllers, and then tiers 1 and upwards are sort of servers and machines that you can't protect as much. Yeah. But the idea behind this is your ADFS server has always been important. This makes it more so, because if an adversary gets in here, fine, EDR should stop them. But they don't need to get to your domain controller to get this. And once they've got these passwords, password reuse means, hey, they're probably going to get in through your VPNs if you don't have 2FA there. So you're going to end up playing whack-a-mole. It's much, much easier to reject them from initial access than it is to start playing whack-a-mole once they start getting to your tier 0 machines.
So again, remember, this is all in the realm of possibility, right? This isn't necessarily in the realm of likely. And I really want to drive that home, because like for a lot of these webinars, when I see them, people show off these flashy attacks and then they say, the sky is falling, drop everything that you're doing right now and go hunt for this in your environment. That's not what I'm trying to show here. I picked these 3 techniques specifically because one of them, Evilginx phishing, is of course extremely common. Session token theft is extremely common and dangerous. But the other 2 are illustrative to show the line between identity and on-prem is blurred to the point that you can leverage one to access the other. And so that is the real take home here. Is that we're playing 4-dimensional chess now. And so you've got to constantly be assessing like, okay, even in my on-prem environments where my users are logged into M365, what are the attack vectors? Can access tokens be stolen from processes? It turns out they absolutely can. Looking at it from the other direction, if I have a global administrator who is compromised in my Azure M365 tenants, what damage can they do to my on-prem environment? Turns out Skeleton Key is a great example of how to do that. So there's like, it's another, that's really the point that I'm trying to drive home here. I can fill an ocean with the stuff I don't know about Azure and M365 right now. And these are just some of the mental models that I'm kind of like piecing together to try to attack the problem. Is that there's a new dimension here, and there's a lot of design space for adversary tradecraft and emergent tradecraft in that new dimension. That's really kind of what I'm trying to drive home.
And Matt, I think what's extra scary and spooky about what you're trying to describe there is the push to go to cloud by Microsoft and by others are kind of, they're heralding it as a, hey, this is going to solve a lot of security problems. And they are, like conditional access policies are just one example of it. This is going to solve problems. But when we're linking things on-prem, and by the way, even if things aren't linked on-prem, without appropriate security posture, you're still going to have security problems. You've just taken up the problems you had on-prem and you've moved them to the cloud. And adversaries are quite innovative. And by the way, I think, Matt, we were speaking about this before, what the likelihood is of various different attacks. Not every adversary is going to backdoor your ADFS server. Okay. Yeah. But we see a butt ton with our MDR of Microsoft 365 of adversaries getting in, and they've no desire to escalate their privileges because they're just going to control an account, create various inbox rules to make sure that their bad stuff doesn't get detected. And then they're just going to send stuff out on blast. And that's what you're going to see the bulk of. So sure, you don't have to worry about the most nuclear dangerous things. But chances are your security posture to detect the easy things can also give you a good security posture to detect the harder things. Yeah,
absolutely. The common, and I'm seeing this time and time again, the common and simple attack chains in M365 are the ones that are gonna nail people. Like just time and time again, it's the session token hijack into business email compromise, into get out of the environment because you as the attacker have done everything you came to do. I want to just kind of leave the field open for questions now. I mean, we've got a couple more minutes here, but yeah, thank you for coming along with us. Like I said, I've got a long journey to go to understand M365 and Azure and just all of all of the attack vectors and all of the kind of all that space in the new dimension to play around with. But yeah, I'm having a blast with it so far, and I've got a fantastic team as well here to show me the ropes. So.
No, Matt, this has been wonderful, and you put those slides together. And when you did a demo, I think when folks do Tradecraft Tuesdays, they're not brave enough to do a demo. So you were part of an elite group, man. But hey, we've got some questions, and I don't want us to run out of time before we get to these questions. So Mark says, do you have suggested training or resources for configuring conditional access policies? So Mark, there is going to be a Huntress blog again for free that comes out all about this, but there is one. It's a really good blog. I'm actually going to throw it in chat right now. And it actually talks about some of the mistakes that folks can make for conditional access policies. I think it's a really wonderful blog. Check that one out. There's also this Microsoft one. Your mileage may vary. I've thrown that one in chat too. Ryan wants to know if you're using password hash sync. I don't think so. If you're using password hash sync, I don't think skeleton key will work. But
no, that is not. Yeah, that's this is effective against pass-through authentication. Hash syncing is another kind of. There are other attacks that work against that, but a skeleton key is not one of them. No.
Yeah, hash syncing should be pretty trivial with AAD internals toolkit. I'm like trying to remember documentation right now. Ryan, if you want, reach out to me on Twitter, and I can probably give you a better technical answer to that, dude. So we've got Dylan. Can you recommend any resources? So I personally, and I think Matt would too, recommend Lena's course.
Yes.
I don't actually remember what it's called right now.
Yeah,
and I don't
remember Lena's Sintra training, attacking and defending Azure and M365. And her Twitter handle is Inverse Coast, and her training company is called Sintra Training. But yeah, there it is. And yeah, it's phenomenal. Like through and through, fantastic information, covers the attacks and also the detections and the mitigations. So yeah, highly recommend that one.
Cool. We have Catherine. Does MS Core isolation memory integrity setting help mitigate token mining from application memory?
Let me think. I'm not sure, but I am intuiting no, because you're only dumping out the running process memory of a process in your current integrity level. And so I don't think this is not like dumping out LSAS or carving into something, from the system, NT authority system level. Like this is like you as the user in, desktop hostname / Matt, I've landed in that context, and Matt happens to have Excel open, and that's a lateral movement in privilege and context level. So I don't think that's the case, but I don't know for sure, and I'd have to do a little research to figure that out.
Cool, and this may be our last one due to being respectful for time. So Joe says, hey, so TLDR, what do we advise they do if they're just exporting these logs? They're going through Excel. So Joe, one of the first things I would do, man, so Excel's good if you could be a power user or whatever. Push this to a free scene. You can spin up a free open search.
Elastic,
yeah, and just push those in there. The other thing I'd suggest is, so this is a pain in the butt, but Microsoft default logs suck. What you want to do is turn on quite a few of the diagnostic logs. And what I'm going to do is I'm just going to copy paste some of the logs that I would recommend turning on and not turning on, just making sure you're exporting. Give me 1 second. Oh, damn, that formatting sucks. Yeah, that'll do. So that's just what this isn't like, if people disagree, that's fine. I don't actually care. But like that's what I would want to make sure I'm exporting if I'm going to do it myself. Joe, I would suggest I doubt you have to do this yourself. DM us afterwards. I'm not going to push the Huntress product, but like I don't think exporting this to Excel is worth your mileage, dude. Like there are much easier ways that you can do this.
Okay, well, we're a little past the hour now, so I think we can wrap it up there. Any last words, Trey? Well, not like last words, but any words?
No, please do it, dude. So Matt, where can people find you, man? You've been wonderful. You've given us live demos. Where can people find you? How can they get
I'm not I got my Twitter there, but I'm not really using Twitter much anymore. I'm on LinkedIn. I've got my notes page, notes.huskyhacks.dev. And I've got a YouTube channel where I upload a video every new age, the procession of the ages. Like I think we're in Aquarius at this point. Every time that changes over in the celestial clock, I'll upload a new YouTube video. But yeah, I don't know. Yeah, just LinkedIn. Just DM me on LinkedIn or Discord. And yeah, I'm just Husky Hacks everywhere.
Cool. No, thanks, Matt. And yeah, folks, make sure as well that if you didn't manage to get everything in here, there'll be a recording. We also have folks, Matt, saying like, hey, can you throw all of your recommendations in a blog? So there is a blog that's due to come out real soon on conditional access policies. What we may do is serialize that a little bit and just turn that into some general Office Microsoft 365 and Azure Entra ID guidance. But folks, that will take a while to come out because it is nearly Christmas. But cool, right, guys, thank you so much. This is wonderful, Matt. Thank you so much. We're going to end the webinar here. And folks, remember, if you have any questions, you can just reach out to us on any social media you can find us on.
Thank you, Dre. Thanks for coming along with me. Thank you, everybody, for hanging out. And until next time, stay hacking.